Okay, so let's take a little look at simplifying algebra. So yesterday we looked a little bit at substitutions. That was replacing the letters with numbers when we know their value. Simplifying is not like that. Simplifying is when we still don't know the value of those pronumerals or variables, those letters. We don't know what x or y is. But what we want to do is for the formula, or the expression, we want to make it a little bit cleaner, I suppose. Put together stuff that fits together. So a very simple example of simplifying is you can write an expression of the number of children in a classroom. 1 plus 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 1. And that would be an unsimplified way of saying how many children are in that classroom. Well, you just do 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. There's 9 children. So you could have done 1 plus 1 plus 1 children, or you could have just said 9 children. Okay. That's simplifying. So this will focus a little bit more. That's in essence simplifying. So for something similar, we could use apples. If you want to say you have 1 apple plus 1 apple plus 1 apple, and you leave the house with 1 apple plus 1 apple plus 1 apple, no one talks like that. You left the house with 3 apples. So you just combine them together. Although they are all separate entities, I suppose, 3 separate apples, you would combine them together to get 3 apples. And that's what we're going to do for algebra. If we have multiple entities that are the same, or variables that are the same, such as x, so if I have x plus x plus x, you could leave it.
X times 3.
It's x times 3, or 3x. Yeah. So this way we said it wasn't apples times 3 up here, it was 3 apples. It's 3x. Yeah, so what this is called, this is simplifying. When you combine these like terms. So these terms are alike. They're alike. Apples can be added to apples and x's can be added to x. Does this work for subtracting as well? Yes. So you can subtract. So if I have 2x's minus 3x's, I can combine those like terms. Well, I know that 2x's is an x plus an x. And I know if I subtract x 3 times, minus x minus x minus x, that's subtracting 3x's. So, well, if I have one and I subtract one, I have one and subtract one, I'm left with a negative x. So I can combine these to be negative 1x. So 2 of them, take away 3 of them, we're left with negative 1x. What happens if the letters are different? So we get something like x plus 3, y plus 2x plus y. Anyone type in the chat what that would be simplified to? Yeah, a few people got it. Yep. So we can only add apples to apples and oranges to oranges, or x's to x's and y's to y's. Wouldn't make sense otherwise, because x could be any number. But I know that's the same number. So if x is 100 and y is 1, it wouldn't make sense to add these two together. So, but I can add these two together, and they are called like terms. Now I could do a line of working for this, and I could just rearrange this and say, well, x plus 2x gives me a total of 3x's, and 3y plus the y at the end gives me a total of 4y, and then recombine them together to get 3x plus 4y. So that plus that is 3x's, and that plus that is 4y's, and recombine them. That's a slower way of doing it. I could just look at it. X plus 2x's gives me 3x's, and 3y plus y gives 4y. Okay. So we have to be pretty confident that things are or are not like terms. So I'm going to, like or not, we're going to go through a little competition here. Not a competition, but I'm just going through 3 things. Right. So if I have the term 3fg and 4gf, are they like terms or not like terms? Type in the chat. Like or not? Okay, a lot of nots. All right. They're like terms. They can be combined to form 7fg or gf. Because we know, yeah, commutative property of f and g. F times g is the same as g times f. This is multiplying. So I just can write them in the other. This is just written in the alphabet. I should write A, B, C, D, E, F, G. But this one's written wrong. But it's okay. G times F is the same as F times G. So as long as they contain the same letters, they are alike. Okay. So what about this? A, B, and 6AB. Are they like terms or not? Type in the chat. Can they be combined? Okay, if they are like terms, which they are, what is the answer then? They are like. So what is the answer to them added together? 7 ABs? Yes, because this is 1 AB without a number in front. It is 1, so 7 AB. So I'm sure you've done this before. I'm just going over old ground with you. Right, what about this one? X squared and X. What do they form when they're added together? Are they like or not first? Yeah, they look alike, don't they? And then tell me the answer. 3x. Okay. Everybody happy with 3x? These are not alike. Not alike. This is x times x. This is x times, well, 1. So there's a difference here between 2x plus x, which gives 3x because they are like. That's 2x's plus another x, that's 3x's. This is a different term. This is x times x plus x. Now, that doesn't go together because x times x, if x was 10, that would be 10 times 10, which is 100, plus just 10. So they are not like terms. So they, if you were to add them together, they just form what they are, x squared plus x. They are what they are. They can't be shoved together in this case. All right, let's do maybe a couple more. What about 12xyz plus 7yz x squared? Not. Yes, they're not. They're close because xyz is in them both, but this little squared has messed it up because 12xyz is 12 times x times y times z. And this is 7 times, well, I could put x times y times z. Now these would have to match perfectly. And of course, there's an extra x here that's not here. Okay. xyz and zyx are the same, but because I put this little squared here, they're not the same. So xyz can be added to zyx. That's okay. They are like. Okay. Is that Pauline with the hand up?
Yes.
Question?
Does not alike mean that they can't be added?
If they're not alike, they just can't be simplified. So this is as simple as it gets. It's like adding apples and oranges. If I have 3 apples and 2 oranges, are these alike fruits? Not alike. I can't have a hybrid 5 apple orange. What does that look like? No, it's just, you just have 3 apples and 2 oranges. But if I have 3 apples and 2 apples, well, yeah, we can simplify that down. They're alike. Yeah, you can come up with a weird name for an apple and an orange together. But this is fine. This can be done. It's fine to leave it like that. It's fine to leave it like that. But in algebra, we just like to tidy things up as simply as they can. Okay, Ethan, you want me to explain for x, y, z? Yep. Okay, why are these alike? Let's look at this. X, y, z and y, z, x. Oh, I've written them wrong. Z, y, x. Okay, why are these the same? Well, this is x times y times z. So let's give x, y, z numbers. X is 2, y is 3, z is 4. So let's test this formula with numbers. So 2 times 3 times 4. Okay. Does that give the answer, same answer as 4 times 3 times 2? In other words, is it the same number that we're adding together? Yes, it is. So I could say 3 of those and 2 of those. Well, what is one of those? If this makes the same answer, I can do 3 times it and 2 and add it together. So one of these is 2 times 3, which is 6 and 24. And z times y is 12 and 20. So it's 24 as well. So remember, I've changed it to 3 times it plus 2 times it. So I can say, okay, I don't need, that's okay, because these can be added, it's 24s. It's 3 24s and 2 24s. That's 5 24s in total, if I wanted to give them values, numbers. So 5 24s works out. Now, if this didn't work out as the same number here, if this was 3 20s and 2 24s, they can't be added together like this. Okay? So what you need to remember is if they're the same number of letters, or just the same letters, they can be combined, added or subtracted. If they have different letters, they cannot be combined, or different number of letters. That's where the squareds come in. Okay, now.
That's like, right?
Sorry?
So that's like, right?
Not catching you. Say it again.
That question is like, right?
Can you quit? Type it. I can't.
He's saying that if that question is like, is that question in the like section?
Oh, that'd be like, yeah, sorry, yeah, thank you.
Yep.
Someone's microphone's better. That's like, yeah. So if they can be added together, they're like. All right. All right, so that will cover all green and yellow. For blue, I put in a little bit of something called the distributive rule. Sounds difficult. And that's used when expanding, I'm running out of room, brackets. And we'll have to come back to this again in class tomorrow. But distributive rule is a pretty simple concept. I'm saying it's, if I want to multiply something by 2, but I want to multiply 2 things by 2, I can say 2 times, and I want to multiply it by 3 and 4, and add the result. So 2 times 3 plus 4. Now I can do this 2 ways, and this is the distributive rule and the normal way. Normal way, you would just do 3 plus 4 is 7, and then you would multiply 2 times 7 to give 14. The distributive rule says that I can multiply them separately and kind of break my order of operations rules. I can multiply first, do 2 times 3 plus 2 times 4, because they both need to be multiplied by this 2 outside. So maybe I'll do the multiplication first, then add. Does that work? Well, 2 times 3 is 6, 2 times 4 is 8, and 6 plus 8 also gives 14. So they're both the same. So it does work. Now, why is this important? Well, what happens if we don't know one of these numbers? Yeah, so that'd be BODMAS or BIDMAS. You should, and we're used to using this method. And you would use it if it was an order of operations, BODMAS, BEDMAS question. Like this, that's fine. But what happens in algebra is we don't know one of the terms. These terms are not alike, so they can't be added together. So what do? Do I panic? No. I then simplify it by just multiplying both terms by 2. 2 times x to give twice x, and 2 times 4, so that's what I drew this little line for, to give 8. And that's it simplified. I still can't add those terms because they're not like, but I've simplified. I got rid of the brackets and I've multiplied. And that's called the distributive rule, which we'll look at more tomorrow. So that's only in blue. There is a worksheet which I'll post in a second. This stuff is for green and yellow. Just adding and subtracting like terms. Okay. Hold on. Let's have a little look at what the worksheet looks like. I haven't posted it yet. I'll post it directly after this. This worksheet will be due tomorrow, so let me just... It should be pretty quick because you don't have to write the questions. It's just the answers. Just want to share my screen and then entire screen, share, switch to that tab. Okay, so this is the worksheet. Green would have to do question 1 and 2. So for green, if I was doing question, let's do question I here. Let's just draw on it. This one, 4e take away e. Are they like terms? Yes. I think almost all of them for green are like terms. 4e take away e. What's my answer to this? 3 e's. So 4e take away 1e. Okay, so that's 3e. That's the example of that one. 4x plus 14x. Many x's are there in total? 18. Let's look at one of the ones in question 2. So there's some unlike terms here. So let's look down here at this one. 18f take away 2f's plus 5. So I can only add and subtract the ones with f. 18f take away 2f. That gives me 16f's. 18f's if I take away 2. 16f's. What do I do with the 5? Do I add it to the f's? Or do I just keep it separate?
You keep it separate.
Yeah, you keep it separate. So it's just plus 5. Okay. So if it can't be added, just keep it, and that's fine. So you're not looking for any final answer here. This is the final answer. You don't have to solve anything. Okay, so that's question 1 and 2. That's green. Don't need to write the questions, just the answers is fine.
Mr. Collins, do we write if they're like or not?
No, you don't need to. Just write the answer. So it should be pretty quick. And you can see then for, well, yellow is going to be question 2 and 4. So yellow, you have to do question 2 as well. Question 4 asks you to simplify and then sub in a is 7 at the end. So you get your answer and then you replace a with 7. So a combination of yesterday and today. And then, yes, Ryan?
Sorry, we can't see your hand on the screen.
Sorry?
We can't see your hand on the screen. We can only see the top part of the screen.
It's not coming up on
No,
screen?
no. He was doing it on a different screen.
Oh,
He was
yeah.
not doing it on the same one.
Switch screens there.
I think he pinned